Hey everyone, I'm Berk Yilmaz. I'm from New Jersey Institute of Technology and I'm a senior electrical engineering student. In today's video, we're going to delve into an exciting Arduino project that combines electronics, programming, and a bit of physics to create something truly interactive and fun. Have you ever wondered how robots avoid obstacles or how cars detect objects in their path? Well, today we are going to build a basic version of that using HC-SR04 sensor, ultrasonic sensor, and an Arduino board. This project will not only teach you about ultrasonic sensors and how they measure distance, but will also use LEDs to visually represent the distance. It's a perfect blend of learning and doing, ideal for beginners and intermediate level students. By the end of this video, you'll have all the knowledge and steps build your own device measurement device which lights up red, yellow, and green LEDs based on how close an object to a sensor. So grab your Arduino, your HC-SR04 sensor, three LEDs, few jumper wires, and four 220 ohm resistors. And let's get started. So let's talk about what an HC-SR ultrasonic sensor is and how it works. This sensor measures the distance by emitting ultrasonic waves and then calculating the time it takes for those waves to bounce back from an object. For our project, we'll be using Elgato as the brain to process this data and control LEDs that will light up based on the distance measured by the sensor. We'll need red, yellow, and green LEDs, each representing different distance ranges. Red for close objects, yellow for objects at the medium range, and green for objects that further away. I'll walk you through the wiring setup on a breadboard step by step because it is important to ensure a proper connection to evade any short circuits or malfunctions. Next, we'll dive into the code. I'll explain each part of the sketch from initializing the sensor to calculating the distance and controlling LEDs. I'll show you how to upload the code to your Arduino, and after everything is set up, we'll test our project. You'll see how LEDs can change as we move an object closer and farther from the sensor. So before delving into the PCB section, I want to say that I'm dividing this project into two parts. In the first part, we were going to deal with the LEDs and how they work. And we are going to build a simple Arduino code for LEDs to ensure there are no malfunctions in our uh, any of our LEDs. And then we're going to add our sensor on our breadboard. So let's get started. The first things I want to connect my ground to my breadboard. To do that, um, you'll see a GND in your Arduino or Elgato board. Connect one jumper wire to the GND part, and with the other line, um, see a minus section and connect your jumper wire to the minus section. This will make this section all be grounded, and I'm doing that for both sides. Here. So I'm going to attach my red LED first, and we're going to connect our red LED to pin 11. We have a ground and we have a 5 voltages, so we need resistors. Do not ever connect directly LEDs to Arduino board because the 5 volts are really great voltages for simple LEDs. So to do that, we need to get a ground because in every line of this section is a ground. We can use any of them. I'm using this part, and I'm connecting my jumper wire to another port here. So in each LED, there will be two sections and uh, two parts. One is longer and one is shorter. Use shorter one for the ground and longer one for the 5 voltages. If you do otherwise, it won't work. So I'm attaching my LED to our PCB, and I'm adding 220 ohm resistors. You can use higher or lower um, levels of resistors, but uh, the optimal ohm is 220. So I'm attaching my resistor on our breadboard here, and at the end of our resistor, I'm adding a jumper wire to connect my red LED to pin 11. So I'll do that for the yellow one. Get a ground. I want my LEDs to be separate, so I'm using this here, and I'm connecting my ground. I'm using this shorter part for the ground and longer for the 5 voltages. Here I've connected, and I'm adding a resistor to ensure voltage is not big for my LED. Here I've attached it, and I'm using a jumper wire to connect my yellow pin to pin 12. And I'm doing the same thing for pin for LED, green LED. I'm using jumper wire to get a ground, and here it is grounded. So as I mentioned before, I'm using the short part for the low voltages. And here I've attached my green LED to our breadboard, and I'm using a 220 ohm resistor to ensure it's safe. And at the end of the resistor, I'm using a jumper wire and connecting to the pin 13. Here it is simple, and we have built a simple LED, and next step is to write the codes. In Arduino, we write a script uh, that is sequentially turns on and off 3 LEDs, red, yellow, and green. It's a simple yet effective demonstration of us using a digital output with Arduino. So I'm going to explain each and every part of the code. So before writing the setup, I'll define my pin, my red, yellow, and green pins. Um, Using define makes code more readable and easier to modify. So instead of remembering which pin number corresponds to each color LED throughout the code, you can simply refer them by name such as red LED, yellow LED, and green LED. And this approach will enhance code's maintainability, especially in more complex and projects where pin assignments might change. So I'm defining my red LED pin to 11, and I'm defining blue LED pin to 12, and I'm defining my yellow, my green LED pin 13. So here, setup. The setup function runs when the Arduino is powered on or reset. It's used to initialize the pin modes. Here the pin mode function is called for each LED pin, setting them as outputs. This is crucial because the pins need to provide a high, 5, 4 or low voltages signals to turn the LEDs on or off. Setting a pin as an output configures the Arduino's microcontroller to drive current out of the pin, enabling it to light up an LED to connect it to it. So here you're going to write pin mode for each every LED pins. So here pin 12, pin 11 is output. And here pin mode, and I'm writing for the yellow one, yellow LED pin, which will be the output. And I'm going to use one green LED pin, which will be the output 13. And loop function. The loop function contains the code that is executed repeatedly, creating an ongoing cycle of actions. Um, in in this part, we are going to turn our LEDs on, we're going to pause, and we're going to turn off LEDs off. So digital write function is used to set a pin high, which turns the corresponding LED on. This is done sequentially for red, yellow, and green LEDs. After each LED is turned on, we're going to add delay, which will be 1 second, um, which pauses the execution for 1000 milliseconds, which is 1 seconds. This makes LED remain on a visible duration, making it easier to viewer to observe. And after following the pause, we're going to use digital write, which is called again for the same pin but set to low, which is 0 volts, and turning the LED off. So here's the demonstration how it works. So as I said before, I'm going to digital write my pin red LED pin to high, and I'm going to add 1 second delay, which is 1000 microseconds, milliseconds, I'm sorry. And we're going to use the same digital write function for turning off the LED. So we're going to do that for every LED. For the yellow part, yellow LED pin, we're going to set as high, and we're going to add 1000 millisecond delay. And after the delay, we're going to use digital write function once again to turn yellow LED off. And for the final LED, I'm going to write green LED pin to high, and I'm going to add 1000 millisecond or 1 second delay, and I'm going to digital write green pin to low. So this will turn off the LED, and I'll add 1 second delay at the end because before repeating the cycle. So let's verify the codes. Connect to see if we did any mistakes. We did not, and upload it to the Arduino. But before uploading it to Arduino, make sure it is connected to Arduino Uno, and the port is COM4, or in this case you can use COM3 or 2, but I'm using COM4. So we already verified, so you're uploading it to the PC. So here, so as you can see here, there's a live demonstration, and each LED is working fine, so there are no malfunctions in our breadboard. So part 1 is completed. We know that there are no malfunctions in our LEDs, so we can add our sensors on our breadboard. We are using HC, as I said before, we are using HC-SR04 sensor, and in this sensor there are 4 pins. The one is VCC and ground, eco and trig. In eco, we are going to use 220 ohm resistor to ensure there are no voltage differences. So to connect your sensors on your breadboard, just connect it here, and yep, it is connected. So for the VCC, I'm connecting my VCC here because we're measuring the distance. I don't want anything in front of our sensor, so I'm attaching my jumper, one of my jumper wire here and to here. So here is a VCC, and I'll get another jumper wire here and to our 5 voltages or VCC, but in this case it's 5 volts in our Elgato. So we did that, and for ground, for trig, we're going to use same, but connect trig to pin 9 in your Elgato. So we connected that, and for eco, don't forget to use 220 ohm resistors, which of the voltage is. And like I said before, I don't want it to connect it here because I don't want anything in front of the sensors. So I'm connecting my jumper wire here to here. And I'm connecting my resistor here, here. And I'm using another jumper wire to connect the echo to pin 9. To pin 10, I'm sorry. So I connect my echo. And lastly, I'm going to connect my ground to the ground. This is relatively hard because of the jumper wires. So this can take a little time. Okay, I connected it. So lastly, I'll connect my jumper wire to the ground. And here I'm not just connecting the ground. So we completed our breadboard and let's see if it works. So first things first, connect your Arduino or Elgato board to your PC. And once you connect it, the red lights will show up. So as we did in the LED section before, we're going to define our pin numbers. So let's get started with the sensors. So sensor has two pins, two pin inputs. One is trig and other one is echo. And we're going to attach our trig to 9 and echo to 10. So here I'm defining my trig to 9 and I'm defining my echo pin to 10. Here I'm defining my red LED pin to 11 and I'm defining yellow LED pin to 12 and defining my green LED pin to 13. So setup. We completed that part and here setup. So the setup function initializes the pin modes and starts serial communication. Serial begin 9600 sets up serial communication and 9600 bits per second, allowing data to be sent from Arduino to computer. The pin mode function configures the trig pin as an output from the Arduino sends pulses to the sensor, the echo pin as an input to receive the pulses reflection from the sensor, and the LED pins as the output to control to the LED states. So I'm going to write these to our codes. So serial begin will be 9600 and we're going to define our pin modes. So here the trig pin it will be the output and echo pin will be the input. So here and all the LED pins will be the output. So I'm going to write red LED pin as an output and yellow and green ones as an output. Here we define our pin modes and we can go to the loop section. So in this example, loop section is a little bit complicated. Um, in this case, the loop function is where the distance measurements and LED control happens, repeatedly executed. So we're triggering the sensor. It starts by ensuring trig pin is low, then sends 10 microsecond pulse. This triggers the sensor to emit an ultrasonic wave. Then we will measure the distance with pulse in, echo pin high, measures the time it takes for the echo to return, and the duration used to calculate the distance in centimeters. So before explaining all of that, uh, I'll write the codes. So we are defining long duration, long duration, and centimeters. So I'm digital write. I'll explain every code in a second. I'm just writing, and we're going to delay it for 2 microseconds. 2, and we're going to do the same thing for high. And we're going to add 10 microseconds for delay. And we're going to digital write. Big pin low. So, okay. So this part basically triggers the sensor. It starts with low. By ensuring the trig pin is low, then it sends 2 microsecond delays, and then it triggers the ultrasonic wave, and then adds 10 microsecond delay. So here is a crucial part for our experiment, and we're going to write a duration. Before do that, I want to, okay. So we need to define a duration. So duration is pulse in, which will be the distance. So what I did here is the pulse echo duration echo. Sorry, I go pin too high. Okay. Yep. Okay, it's correct. So pulse in echo pin high measures the time it takes for the echo to return, and this duration is used to calculate the distance in centimeters. The speed of sound is approximate as 0.034 centimeter slash microseconds, and the distance is halved to the account for the travel time to object and back. So we are dividing this into 2. To do that, we're defining in centimeters, which will be duration times 0.034 divided by 2. And another point is a serial communication. The distance is printed to the serial monitor, allowing for real-time monitoring. So that's why we are using serial print, and we are printing the distance. And we're going to use it for centimeters. And print ln centimeters. So here we're going to use if-else functions based on the measured distance. A conditional block, in this case if-else, controls which LED lights up. If the distance is less than 5 centimeters, the red LED is turned on, and if it's between 5 to 10 centimeters, the yellow LED is turned on, and if it's greater than 10 centimeters, the green LED is turned on, and every LED will turn off. This provides a visual indication of distant ranges. And after that, we're going to delay for 500 milliseconds to the loop slow down and rate of measurements, making delayed LEDs change observable. So here, for our first if loop, if statement, if its centimeters is lower than 5, we're going to say digital write red LED pin high. So this will turn on the red LED, and every other LED will be turned off. So yellow LED pin will be low, and green LED pin will be turned off. So we're going to do that for basically every single one. So else if centimeter is greater or equal to 5, or centimeter is lower or greater than 10, digital write will be the same, but except a red LED will be turned off, and yellow LED will be turned on. So I'm going to change this high, and else everything will be similar, except in this case we're turning our red and yellow LED off, and green LED on. So green LED will be high, and I'm adding 500 millisecond delay. No conditions. Yep. And I'm adding 500 millisecond delay. Let's check if we get any errors and verify the codes. Yep, we do. So here's a great way. Expect declaration for token, and I probably forgot to write. Okay, here's this, here's this, here's this, and okay, I forgot. I'll sketch and upload first. Okay. So I think we have done it. So so to measure it, as you can see here, there are no obstacles in our path, so it is green. So if I have an obstacle, it will be yellow, and if I have an obstacle, it will turn red. So this is the project. I hope you guys enjoyed it. It's a fun project, and it is simple to do. It is relatively simple to do. Hope you guys like it. Thank you for listening.